Okay, so today we're going to figure out how to find the sum of an infinite geometric series. So even think of what I did. Calculator drop. Way down. Okay, we're going to find the sum of an infinite series. What does infinite mean to you guys? Never ends. And guess what we're going to do? We're going to find the sum of something that never what? Ends. Does that even seem possible? No. So guess what? It's possible. So we're going to figure out why it's possible. Good to go? And another formula, and you're going to have a formula sheet next week, so that's going to help you with the, hopefully with the test. So, okay. Part 1, we're going to look at different infinite. It's ... means it goes on and on and on and on forever. And we're only studying what today? Geometric. No arithmetic, only geometric today. So, what's the quickest way to figure out what the ratio is? You're going to divide 243 by 729. And isn't it 1/3? Okay, and then this one, let's just do this one really quick. The fastest way to figure out the ratio is 5 divided by 2, which is 2.5. So far, so good? Okay, do you notice that this one is less than 1. This number is less than 1. It's 1/3, it's a fraction. Do you notice that this number is greater than 1? So if the number is a fraction, it's converging. If the number is greater than 1, it's diverging. Converge, if you look it up in the dictionary, means it gets smaller and smaller. These numbers are not getting bigger. These numbers are getting smaller and smaller, aren't they? 729, 243, 81. What's happening to these numbers? They're getting bigger and bigger. So if your series is getting smaller and smaller, it's called converging. If your series are getting bigger and bigger, it's called diverging. So determine whether each is converging or diverging. That's all you're doing in part 1. This one's getting smaller and smaller. It's converging. I'm just going to use the C for converging. This is getting bigger and bigger, and it's diverging. And that's all we're doing in part 1. The only thing you're doing is figuring out what the ratio is. And once the ratio is determined, then it's a C or a D. Anybody want one more of those, C or D? You can only find the sum right here. You can only find the sum of what type? Converging. You can only find the sum if it converges. So, this is getting bigger and bigger and bigger. The sum will just keep getting bigger and bigger if you think about it. Wouldn't that make sense? Wouldn't the sum keep getting bigger and bigger in this one? But what about this one? If this is 729, 243, 81, isn't the next number going to be 27? A third of 81 is 27. What's a third of 27? 9. What's the next number? What's a third of 9? 3. What's the next number? What's a third of 3? 1. What's the next number? 1/3. And before you know it, like 1, 2, 3, 4, 5, 6, 7, 8 number, what do you think the 20th number is going to look like? If 1/3 is 0.3 repeating, what do you think the 20th term is going to look like? Isn't it going to look something like 0.0000000, I don't know, 21? And what do you think the next term after that's going to be? So what happens if you add this to all of this? Is it going to make much of a difference if you add? What about the 50th number? Won't the 50th number be even smaller than that? So do you see how you can find the sum if it's converging? Because the numbers are getting smaller and smaller, right? And pretty soon, it's not going to matter because it's going to be so close to what? 0 that it's not going to make a difference, right? But these numbers, if it's diverging, can you find the sum? No, because it keeps getting bigger and bigger and bigger. There's no way you can find the sum, right? You guys getting that? You get it? Okay, so part 2. Here's the formula to find the sum of any infinite series. The sum of any infinite series right here you need to know what the first term is. It's usually given to you. All over 1 minus the r. You have to check to see if your r is less than 1. If it's a fraction, then you can find it. If it's greater than 1, you're going to write no sum. Some of these you won't even be able to do today. Good? So, here we go. It starts out being 3. I like putting that in decimal form. Starts out being 3. The next number is 3/2, or 1.5. The next number is 3/4, which is 0.75. And it goes on and on and on and on forever. Are these numbers getting smaller, or are these numbers getting bigger? They're getting smaller. So can we find the sum if it's getting smaller? Yeah. So we're just going to plug it into this formula. What's the first term in this problem? 3 divided by 1 minus, all we have to do is find the r, plug it into your calculator, done with the problem. And the ratio is 1/2, yes. 1/2 of 3 is 1 1/2. 1/2 of 1 1/2. 1/2 of $1.50 is 75 cents. So again, you can use 1/2 or you can use 0.5. What should you do first? You should probably do 1 minus 1/2. What's 1 minus 1/2? 1/2, right? Then take 3 divided by 0.5. What's 3 divided by 0.5? 6. Done. If you added up this infinite series all the way out to 1,000 terms, if you added up the first 1,000 terms, what's it going to get closer and closer and closer to? What's the sum going to be? 6. Do you guys believe me that it add up to 6? It'll never go past 6. Everybody understand why it wouldn't go back past 6? Because those numbers are getting smaller and smaller, that it's not even going to matter anymore, and that's why it's only going to get to 6. The first term is 3. The sum of the first term is 3. The sum of the next two terms is 4.5. When I add these up, when I add this up, isn't it getting closer and closer to 6? It'll never pass it, believe it or not. I made them do that one year. I made them go out to the first 25 terms to prove to me that it'll never pass 6. But I'm not going to make you do that. So, okay, let's do another one. Find the sum. Find the sum. So, I'm just going to find the ratio first. Well, where did I put that? Starts off with a negative 4/3, which is a negative 1.3 repeating, and then it goes to a 4, and then it goes to 12, and then it goes to 36. What are these numbers doing? Getting bigger, right? Some are getting bigger, but isn't it times a negative 3? Isn't it times a negative 3 for the ratio? So, these numbers are getting bigger and bigger. We're not going to be able to find the what? The sum. No sum. The rule says you should check if it's the absolute value of r. Absolute value of r. So, even though that this is a negative 3, the absolute value of that is 3. And that's why you can't do it, because you actually take the absolute value when you check it. And now this will be in the notes as they listen. Hello? Yes. Yep. You're supposed to go to the gym for practice. Graduation practice. That's where everybody else is. You're in choir. Anybody else in choir here? We're going to finish this in a few minutes. We have a couple more? Yep, one last one. One last one. So, you're supposed to find the sum of the infinite geometric series. The first thing you have to do is change this into a series, just like we've learned. In place of k, this is going to start out being a 1. What's 1 minus 1? 0. Anything raised to the 0 power in math is 1 times 2. The first number is 2. I'm going to do it one more time. I put the 1 in there. 1 minus 1 is 0. 1/3 raised to the 0 power is 1, and 1 times 2 is 2. And I'm going to do one more because I need to figure out what my ratio is. My next number is not going to be a 1, it's going to be a 2. What's 2 minus 1? 1. 1/3 to the first is 1/3 times 2, 2/3. Plus, and it just keeps going. Are these numbers getting bigger or are these numbers getting smaller? They're getting smaller, so can we find the sum? And the formula is A1 over 1 minus R. It's probably one of the simplest formulas out there that we've learned, right? What's the first term? 2 divided by, do you know what you're multiplying by? Can you guys tell? 2 times what gives you 2/3? 2 times 1/3, right? Put 1/3 here. Now just use your trusted little calculator and it should give you the final answer for the sum. What's 1 minus 1/3, if anybody cares? 1 minus 1/3 is 2/3, right? So you're taking 2 divided by, on your calculator, parentheses 2/3 probably, if you want it to work, which is 2 over 1 times 3. You should get 3 for your sum. Any questions? Anybody want another one? Anybody want another one? Look to see if it's getting smaller. If it's getting smaller, you can find the sum. If it's getting bigger, you don't even have to do the problem. Just say no sum, and there's going to be a bunch of no sums today. Yeah. 16 through 31, not 28. You don't even do the sum. The first part, they only want you to figure out if it's a C or a D. That's all they're asking you to do in the first part. So you don't have to write converging or diverging. You can just write C and D. Good to go? Turning it off, at least it's off.